Hello and welcome everyone to MSC Software's webinar series. Today's topic is Simulation Process and Data Management Deployment, Lessons from 15 Years of Experience. My name is Farnaz Jadbavi and I will be the host for this webinar. The presenter for today's session will be Michael Schlingrich.
Okay, so first of all, welcome everybody to the webinar. It's a pleasure for me to give you a presentation on experience and lessons learned in 15 years of experience of deploying an SPDM system. That's quite of a challenging presentation in some respects because it's not talking about feature functionality, but much more about how do you approach and deployment of an SPDM system. What four issues do you have, which risks are there, which challenges are there, and then give recommendations to you in terms of how to address those challenges and what are, in our eyes, the right approaches based on our experience we have with our customer base. Now, what I want to say right here is, just to set the context, every project is unique, so what I'm going to present right here are common understanding, are common themes, common aspects of what you see in SPDM deployments. Of course, there will be for each project specific aspects, so what I'm going to present is not a cookbook of 100% with 100% guarantee of a successful deployment, but rather of general themes, general concepts which you will be encountering while deploying a simulation process and data management system. So first of all, let's get started. Why are we talking about 15 years of experience? Actually, it is 17 years of experience. We have, and I'm here since the beginning, since 2000, we have been deploying simulation process and data management systems. Initially at SGI, and then starting with 2001, we were acquired by MSC, and then had many different software releases where we matured our solution from an IT framework over a product to a configurable application, with many releases of our solution SimManager for a simulation process and data management system. Actually, in recent years, I want to point out, not only have we deployed and released versions of the SimManager software itself, but we have started with 2013 with Material Center to build on top of that foundation vertical solutions to further accelerate the deployment process for specific application areas, application domains, currently for materials management and for Adams car simulation processes. We have a strong variety and quite some customers with whom we are working over the past 15 years together, which have shared with us very many of their experiences. And so what I do want to point out right here is our customers have been very verbose in many of international meetings, particularly on the NAFEMS conference, in sharing their experiences with the deployment of the SimManager system. So most of what I'm going to talk about today in this presentation, you can even find in some of those presentations by our customers. These are shared, common experience we have gotten together with our customers in such enterprise deployments. So, with that having been said, I will move on and really start with the first lessons learned. If you're deploying an SPDM system, you are introducing a change in your organization, and you need to be very well aware about that. There will be a change for not only the end users, but also for the methods approach of the methods department, methods user group, and also for the IT department. Things will change as part of a deployment of an SPDM system. So a foundational requirement for a successful SPDM deployment is really that with end users, methods, and IT departments, there's a willingness of the change. There's also a need for an acceptance that we actually need to change for the needs. And you need to have very clear goals and objectives. What do you want to accomplish? Why are we doing this? Why are we going through this pain of change? And last but not least, there needs to be a management commitment. Yes, this is a change we want to do. This is how we want to transform, how we want to move forward our simulation aspects. Okay? So, now, something which is quite obvious is you cannot avoid the change. You cannot kind of like downsize an SPDM solution so that you don't need to change anything. This will not work. It will fail. Maybe not immediately, but eventually. On the other side, you cannot force change. Something we realized is you need to address, you need to focus your end user community. They need to be on board with this change process of deploying an SPDM system from day one. Otherwise, they will not endorse and accept the system. Okay? With that said, we are basically within deployment of an SPDM system in what I would call classical IT projects. That means when you are dealing with classical IT projects, if you go on the internet, if you just browse Google and say, wait a moment, what are the challenging parts of any IT projects? And you basically do a negative search and say, why do IT projects fail? What you will see very frequently are, and this is just a summary I put together based on my research in the internet, is fuzzy goals, over-optimism, complexity, weak ownership, governance, over-engineered thinking, and there is also a management factor of engagement, commitment of management to those projects. So what I want to do in this presentation is, what I want to do in this presentation is I don't want to focus on the generality of lessons learned of general IT projects. There's enough to talk about which is specific to SPDM, and I want to focus on that one. But I want everybody to be aware that all those aspects, all those challenges also apply for SPDM projects, and I will pick up some of them during my course. What I do expect, and this is something which you should be all aware about, is you need to apply standard project methodologies that you have and your company has applied with IT projects around defining use cases requirements, having a strong project management, having clearly defined objectives, managing commitment and management commitment and engagement, and having policies and strategies around risk management. These are general things. I will be not touching on them, otherwise I would be talking for more than 2, 3, 4 hours or even the whole day on all those aspects right here. So let me just focus on SPDM specific topics right here. And I will jump directly in the middle of it and give you also a little bit of a theme of how I structured this presentation. Our approach, and if you have witnessed presentation of myself, you will always see that I always say you should think big, plan small, and act now in doing a simulation data and process management, deploying and introducing a simulation data and process management system. What do I mean? Think big. You need to have an understanding of what will happen within the next 5 years to your simulation. How will things change? What are the trends which I need to support in my SPDM system? And once you have understood this picture, you basically need to plan small. You need to have a tactical approach of how you engage. You cannot just introduce a waterfall concept. And then there's actually nothing hindering you to immediately start to act now. There's no need for delay. So this is my general theme throughout the presentation. What I will do is the presentation is structured in those 3 blocks. So I'll start by basically motivating to you why I feel it's important to think big, to understand what you're doing, to understand where simulation is in 5 years. And then we'll go on into more the tactical side of planning small and acting now around an SPDM project to make it successful at the end of the day. So first of all, this is just a Google search on speed of change increasing. And these are the top 5 to 7 hits I got when I did the Google search. Something you need to realize is we're living in a world where change is actually accelerating. So if you look back 5 years and assess how simulation changed in the last 5 years, and then you project forward, you can assume that things will happen faster than in the past 5 years. Okay, and you need to realize that changes will happen, particularly in IT technologies. There are so many mega trends currently on the market which just are so obvious that they will change the way of how simulation is handled in the future moving forward. So I now summarize a little bit of those trends. It's not a complete list, but it's kind of like hitting on the major topics we have encountered with our customers in the world. So first trend is front-loading simulation. Simulations are moving forward, and I will talk about why they are moving forward in the development process, why you're doing more simulations at the beginning than at the end. There are trends like democratization of CAE, making CAE accessible to a broad community of non-experts. You have, of course, classical things, from presentations when you witness BMW around increasing simulation throughput of really an exponential growth of the simulation. You're seeing trends like multidisciplinary optimization, so not just doing thousands, hundreds of thousands of simulations. And what is happening is, every day you can simulate new stuff. You can simulate even more performance aspect at a higher level of fidelity, introducing much more effects than you've done maybe 2 weeks ago or 2 years ago. And just to highlight a little bit more on this topic, you have effects like materials, 3D printing, manufacturing in general going into the simulation process. And you have control systems. Your products typically get more smarter, more autonomous, and that means that the behavior is much more driven not only from the physical aspect, but also from the control system aspects. And then there are topics which are more IT related, which will also influence quite significantly the approach to simulation around the big data, machine learning, and cloud security. So in a summary, you can be actually sure in 5 years, everything will look different. Why do I stress that? Well, if you think about a role of deploying an SPDM system, it is a requirement that such a system enables and supports these trends. What you don't want to do is you don't want to build a system which actually makes it harder for you to adapt to those trends, to transform to those trends. So you need to open-mindedly, when you look at an SPDM system, understand and always challenge the system. Does it support me in my transformation? In my transformation, I need to do to be and stay competitive. Okay? So what I do want to say right here is you need to assess those things, and you need to not limit your scope and requirements discussion to the current as-is situation, but factor in all those trends that you need to address. So let me go just into the front loading, just to show you the evolution we are seeing in simulation. So if you looked 5, 10 years back, depending on the disciplines, basically simulation was mainly done to validate the design. Over the years, simulation has become driving much more the design, and you have simulation-driven design processes where you're optimizing, where you are predominantly optimizing the design, applying optimization technologies. You're starting with a geometry and then optimizing the design. What really front-loading means is instead of taking a design, which was developed and then optimizing it by optimization technologies and to drive the design forward, actually we see more and more trends that customers up front, before they go into the detailed design phases, to explore the design space, to really do more and more simulation. What I mean right here is, when you see right here the x-axis, this is the time normalized, so you see the development time right here, and you see the y-axis is essentially the number of simulations. What we see is that by going this trend of front loading not only moves the simulation up front, but actually it increases the amount of simulation. And I specifically add right here, this is log scale. So you will see potentials of 10 between those curves in terms of number of simulations that are driven. This is a general trend. Actually, in a book from Stefan Tomka, who's at Harvard Business School, he basically says that as experimentation becomes cheaper, and this is definitely the case because of the computer progression in the simulation world, the way of how you do development drastically changes. And as a consequence of simulation becoming easier, cheaper, that they move forward in the development cycle and they impact more in the front cycle. What that does is this front loading, it makes your whole development cycle faster and cheaper. You know, what you also do with front loading is you do much more knowledge mining of the previous projects. And at the end, because you can do a much more sophisticated exploration of the design space, typically you will end with a much better design than had you initially projected. Okay, so what does that mean for an SPDM deployment? Well, if you think about front loading, what you need to think about is, well, how is the interaction pattern while I move my simulations up forward? How is the interaction pattern with PLM? So the question you need to ask, while in simulation-driven design and simulation-based validation, it was very obvious. Design was first, simulation was second. You need to ask your question, what will be first, simulation or design? You need to ask yourself the question, well, what's the ratio between the variance, the iterations, the design exploration I do in CAE versus what I instantiate, what I design in the PDM system? So the devil's advocate question is really, am I confronted with a flip of who follows where? And I'm seeing in very many discussions that simulation is taking more of a lead role, that simulation is actually moving before design, at least in the areas where the functional, at least in the design space, which is relevant for the functional performance of the product. Okay, so our recommendation and lesson learned is right here is, particularly in the early phases of an SPDM deployment, keep the bidirectional integration between PDM and SPDM system simple and light. Because we recommend that you first need to see how really the interaction pattern works like, particularly as the simulations move forward, as you do more design exploration. The requirements of the PLM integration will change. And so we recommend first to have an SPDM system with some level of maturity in place. And only then do you realize exactly, okay, this is the need I will have in terms of coupling to the PDM or to the PLM environment in general, right here. So this is our first recommendation. Don't tie it too tightly. We have seen projects fail because of a too tight coupling of the PDM system and SPDM system. Second mega trend, democratization of CAE. Okay. Just a short definition of what we understand over democratization of CAE. Think of it as CAE like Google services. So the end user just types in a very simple question, simple, understandable, and intuitive UI. So he just says, please assess this and this and this. Here are my parameters. And the system then goes off, computes, and comes back with really simple answers with all the relevant information for this engineer. What's behind that? Essentially, the bigger engineering community and design community they are just concerned about the answers to their questions. They don't really want to understand the underlying simulation methods used to actually answer those questions. So what that does, this democratization tends is, instead of the CAE analyst day in, day out, responding to requests out of design and engineering and doing simulation process, they focus more on maturing and evolving simulation processes. So take more a role of methods-focused activities, and the engineering community uses those services basically more very indirect. What we have seen with customers deploying such solutions is that there's a drastic increase of the CAE usage by non-experts. One of the key customers we are working with in this respect, and who is a long-term, who has very many years of experience and successes with democratization, is actually GK and Driveline. What it means for an SPDM system is don't just think about data management. You will have always democratization aspects in your CAE work. So plan for the ability that your system, your SPDM system, can host democratized services to eliminate laborious, repetitive tasks of your CAE engineers and really just automate what can be automated as easily as possible and expose it directly to your non-expert usage. That's going to be a trend which I think will be quite strong, or we believe with our customer together will be quite strong over the next years. The third example is really kind of like this more kind of like mixing of domains, having multiple domains. If you think about physical and electronic control system worlds, you don't just have a simple process of I take geometry, I model my physical model, and then I run some use cases. But essentially, right here in Adam's case, you build an Adams model, you have control systems, model control systems, you reduce your Adams model to the critical simplified mechanical model, and then you combine your models to combine simulations of a mechanical and control system, or you can have co-simulations between both of those domains. That is a new trend. And actually, these are two threads which come together, and then actually you have expansions that you take those models, you put them into real-time simulations, you put them into hardware-in-the-loop simulations. So what this shows you is that it's not just a single discipline process which an SPDM system needs to support. It needs to support much more complicated flows involving multiple departments interacting, exchanging data together. So the SPDM system needs to support many simulation disciplines. And actually, something I do want to point out right here, from our assessment, one of the companies which has the most diverse set of data they manage in the system and exchange between the departments is actually PSA in Paris with their SimManager system. And it was actually a nice presentation by Sylvain in the NAFEMS 2013. So to summarize, when you build an SPDM system, you need to have the awareness and the understanding of the trends in simulation. So when I presented this internally, there was one colleague who said, Michael, don't intimidate too much the people. They get scared and they don't want to start with an SPDM system. And I say, however, don't get intimidated by those trends because, and this is now the second part, is plan small. You don't need to immediately tackle those trends. You need to keep them in your backhand. You need to plan for them. But the propose is when you go into the plan small phase, if you go your tactical ways, you don't kind of like try to take it all, but you really become much more tactical by reducing the complexity and the challenges extremely. And this is really the thing you need to do. You need to have an understanding of the big plan, but you need to be smart in how you tackle it and how your progression is. So the key message right here is deploying an SPDM system is not a single one-step process. It is you need to think of it as a phased roadmap. There's no start and end date on an SPDM system. You start and you evolve the system. And you start and you should do cherry picking. You should cherry pick the simulations, the processes which are easy, which have the highest bang for the bucks, and really have a tactical approach. Don't get too complex. Don't get overambitious in the initial steps. Avoid any kind of waterfall approach that you want to pack everything together, have huge departments, committee meetings in setting up an SPDM project. Be very pragmatic, very focused right here. Also acknowledge the fact that not everybody in your CAE organization is ready yet. So you need to, in any case, cherry pick which departments are ready for taking it into an SPDM system. So clear should be, and I hope that I'm motivated that, and I think a big part is you are looking for a system which eventually captures all the simulation domain, all the CAE aspects, because all of them are coupled. But you tackle it by going into a phased approach. Right here is a slide from BMW, which they are using and which they have exposed, where they show exactly the progression of starting in the crash and NVH world, and then subsequently progressing and introducing more and more disciplines to their system. They're now having over 15 years of experience with an SPDM system based on SimManager. Okay. Now, if you look at the timeline, which you cannot see right here, BMW has done it over very many years, and it's actually a very big system. It is our biggest system we have in production in one customer site. Now, the phased approach doesn't mean years. The phased approach can be fast. And something I do want to point out right here, based on our experience we've gotten over the past years, we were able actually with Ashok Leyland to really deploy also in a phased approach. So we also had a sequence in how we addressed the individual disciplines, but we were able to, within 1 year, deploy a durability, NVH, crash, and CFD system in all those disciplines in one system within 1 year. Now, also, what we're also noticing in other projects is by us also having those vertical packed application, that actually further accelerates the process. So when I talk about a phased project, it doesn't mean 10 years or 5 years, but it just means that you plan a tactical plan, that you have a very clear progression in mind where you start simple and then you progress your system and you get more complex. The crawl, walk, run in terms of deploying the system. Okay, so here are just some recommendations of identifying the initial process and discipline. And I want to stress right here, identifying the right initial process / discipline is very critical for success of a project. So you should choose a system where you have a decently matured CAE process with some level of repetition, some routines which are exercised. Okay, you need to have some level of high value by doing traceability and auditing of the data. Okay. Other effects which you should also take into consideration for selecting that is if it's a process or a discipline where you need to ensure high consistency and where you need to ensure collaboration. Okay. What should be clear is you should have a very decent, very clear understanding of the requirements of what you want to accomplish with this system, with this discipline and domain. What you should avoid are, kind of like processes or disciplines with very many external touch points, very many different things happening at the same time. These are typically challenging processes and should be kind of like delayed in the phased approaches. And if you get over ambitious in terms of the simulation process scope, that you want to do too much at once. The second point, and actually I should have animated that so that you don't see it immediately, is you need to identify the right people in your organization leading the projects. So it's not a good idea to assign juniors to such an SPDM project. There needs to be people engaged in the project which have a very clear, holistic view of the entire process. They understand from A to Z the process. They understand crunch points. They understand real pain points in the current process, which should represent immediately addressable areas where you want to do process improvement as part of the deployment of the SPDM project. And last but not least, these people should have a good standing within their department so that they're able to convince and really take a leadership role and pull through their whole organization. Something I want to mention right here is also organizational things will change by selecting those people, because what will happen with an SPDM system is that you will in some way or another be using the system to enforce a specific level of consistency in your processes. Okay, so the people who are defining those processes, who are defining how the systems are behaving, these key people, which I call methods people or have a methods functions, their role will be broadened. They will get more dominant. So in some organizations, I always tell them, look, you have the end users, you have IT, and actually at the end of an SPDM project, you will have a function of methods people which define the SPDM system. Okay? Because of this transformation and this sometimes even new role creating as part of the SPDM project, you have already methods people before, so you have them, but they become much more impactful with the definitions of the methods. So finding the right people is critical, and typically the people you want to have are pretty much always in high demand. And when I do an internal project review on deploying an SPDM system, one of my major questions, particularly when we do risk assessments of the project, is really asking, do we have the right people from the end user community there? Do we have the strong CE people? Because typically that really determines how successful or how challenging an SPDM deployment is going to be. Okay, so that's around the key end user side of the plans model. The other thing is, when you deploy a system, you don't only have the CAE process, so you have a zoo of IT issues. So you're dealing in CAE with huge files, sometimes CFD. We have customers which have 10 terabyte output files from CFD computations. You have many files in the Adams world. In the multi-body worlds, you can have thousands of small property files. You can have different formats, including binary files, including subroutines. All those things need to be managed and stored and moved around within the environment. You have also the integration of the HPC system. We're talking about an SPDM system, okay, and not about an SDM system where only data management is in place. And I want to recall again, I do believe, and we have a strong belief, that the process needs to be coupled, particularly for mega trends like democratization of CAE, but also other trends require a tight integration of HPC into the whole system, like big data, machine learning also requires that to happen. Okay, so you need to integrate with the HPC, and you have security aspects. When you start an SPDM project, typically security patterns in the CAE departments were mainly Unix group patterns, and you're moving now into an SPN system. And that is also something where you need to clearly from day one have IT-oriented people involved in the project. Now, so the IT people should be involved early, ideally at the start of the project. The earlier the better. And something which you need to realize, right, and there's a statement by Yusuf, right, that deploying an SPDM system will expose bottlenecks and issues into the IT infrastructure. So you will, in the deployment, the system and the deployment will finger point to challenges you're having in the IT department. And something I will tell you is, as you deploy a system, as you scale it up, those problems will not go away from themselves. So if you have a problem at the beginning, it will just get worse. So really you need to address and start them. So if you have performance issues around moving data around, that will not change. It will actually just get worse. So you need to address them from day one and not ignore them. Okay. So the SPDM system, as also our understanding, is it needs to architect, it needs to build into the deployment from day one a scalable architecture. Okay. One thing we are proposing is really a structure where the SIM manager system or the SPDM system really controls on the back-end side the data and process management side. We do believe to address democratization, high throughput, multiple disciplines, consistency, security, all those aspects, that data processing and storing needs to go into the back end. So the back end should not only do the solve, but also the pre and post as far as it is automated. The client should become thin. Processes done on the client side should move into the background if they are matured and can be automated. What needs to happen is the client-server communication between the client and the system needs to be minimized. Otherwise, the whole system will not scale. If you have round trips which involve the client, it's not a scalable approach. And by doing that, by doing the separation, by making the client thin, and this is a long-term process. I don't want to pretend that we do everything at day one, But this should be a trend you are encouraging as you're progressing in the deployment of SPDM system, because this also supports major IT trends. This architecture supports and enables cloud-based environment. It really addresses the security issue, because you don't want to have files on the client side, because then they are not controlled. You don't know where they end up. So having the files, having data files, having model libraries, material models, etc., all in the back end, and not allow them to move outside of this zone is actually an increase in the security and the major IT trend of making the client really agnostic. So we have customers which at the end of the day want to drive simulation from an iPad. Okay, and visualization can also be dealt with by remote visualization in this sense. So this is a mega trend, and we believe that such an architecture needs to be put in place so that you can support all the trends I have outlined at the beginning. So now we come to the end of the presentation with Act Now. So really, what we're noticing is to really understand what SPDM systems can do to you, to really understand the impact, you will only realize it to the full extent when you actually do a project. It's not a paper exercise. It's really, hey, let's kind of like get started with it. Let's be smart. Don't be overambitious. Find a project and get started. And what you will notice is that in initial phases, there will be actually considerable refinements of the requirements, objectives, and focus. And independently, if you spend a huge amount of time writing requirement RFI, requirement documents or not, because by working with the system, you realize, okay, these are things that change. People formulate requirements very much out of the as-is thinking. There are very little people which can think about the to-be and then formulate requirement totally in abstraction. Okay, so the point is get started now. And one point why get starting now is important, and I want to end with what I started on the end user side. So I talked very much in my talk about the big vision, where we want to go, but at the end of the day, the success of the system will be defined by the end users accepting the system and using the system. So for the end user, he can care less about the big picture. He, for his day-to-day work, needs to have the feeling, okay, it accelerates my work. It doesn't slow it down. I don't need to really learn very much. And, some ballpark figure of which we are challenging is really that within a half a day of training, the people should be sufficiently understanding the system to use the system. Okay, so now obtaining that, really making sure that the users will accept the system, means before you go into this big kind of like large scope design of a system, you should very early try to get direct, immediate end user feedback from them experiencing the system. And the end users I know of is when I showed them PowerPoints of how the system looks like, they say yes, 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 yes. But really, the constructive feedback only comes when they sit down and actually want to use the system. And when they want to do it with their processes, so not with kind of like an abstract demo system. So they really need to have their system, their processes, and when they start, that's when they really develop feedback. Now, for the success of the project, it's important that you get this feedback early. So as you structure your deployment plan, you need to make sure that very early on you get critical feedback from the end user base. That they say, hey, okay, the system is cool, this is really nice, but this is really awkward. And that you do that feedback up front very much. And something of a caveat I want to point out right here is typically you're not dealing just with on end user basis. You will have the challenge that there are different end user communities, that there are different departments having different emphasis. So you need, and there will be conflicting potentials. This is something you need to work out. This is something which the system needs to support to really address the needs of the individual systems. But the key lesson is right here is plan your project in such a way that the end user community which uses the system has very early exposure. Not to the full system, not necessarily, but to key critical points so that they can provide their feedback. With that, I want to end on the conclusion side. So, what did I talk about? I said, plan for change. You're deploying an SPDM system is a change, is a project of change. Understand the simulation trends. Understand how they impact your operation, how the simulation will be different within the next years. Based on that understanding of the future, develop a tactical plan, a phased approach of how you want to tackle it, and chop it down into digestible pieces to really move forward. And then in the initial phases and throughout the project, focus on the matured process, involve IT, and involve end users early. That are the key recommendations. And so my conclusion is, to be successful, think big, plan small, start now. So I hope this was helpful. Thank you.
Thank you, Michael, for the very informative webinar and presentation. Thank you, everybody, for attending this webinar. Hope to see you all in the future events. Have a nice day.